Okay, so last time we discussed demand and supply. Okay. So we're still trying to understand how prices are determined in the market, in a competitive market. Price of any good or a service, how it's determined in a freely, in a free environment. Basically. There's no outside regulation. A lot of firms competing with each other. So it's a competitive market you're looking at. Okay. And so how prices are determined in that kind of environment. So what I'm going to do today, I'm going to bring both demand and supply, the two sides of the market. You have, demand capturing the behavior of the buyer and supply capturing the behavior of the seller or the firms, right? These are two opposite behaviors in the market because buyers want to pay lower prices for everything and sellers want to receive higher prices for the product that they sell. So two contrasting behavior, and we'll bring them together. And that will allow us to understand how prices are determined in the market. Okay? So in other words, what we are going to look at today is equilibrium in the market. This is not okay, so first let me give you the equilibrium condition in the market. So equilibrium is given by the equality between demand and supply. So when demand equals to supply, we have equilibrium in the market, or state of balance. Okay. So let me draw a simple diagram where you have both demand and supply curves present for some product. So we have quantity on the horizontal axis and price of the good on the vertical axis. So take any product. So the demand curve is going to be downward sloping, following the law of demand. Higher the price, lower is the quantity demanded, other things remaining the same. And supply curve would be positively sloped. Higher the price, the greater is the quantity supplied. Okay. So demand curve captures the behavior of the buyer and supply captures the behavior of the seller. Okay. Two opposite forces in the market. So keep in mind that when you draw a demand curve and supply curve, you are keeping a lot of other variables constant, isn't it? When you draw the demand curve, it is a relationship between price of the good and quantity demanded of the good. Keeping other things remaining the same, other things you keep constant. What are those other things that we keep constant? Just to remember it. 6 factors. Factors that influence demand. What are those?
Like the future predicted price or something?
One would be expected future price, right, of the product. What else?
Prices of related goods.
Prices of the related goods and consumption. Anything else?
The population.
Population. Income of the consumer. Tastes and preferences.
Prices of related goods.
Prices of the related goods, you already mentioned that. So those are the factors that we keep unchanged when you draw the demand curve, right? And similar to that, when you draw the supply curve, you are keeping some factors constant. What are those? Factors that influence supply behavior.
Number of sellers.
Number of sellers,
Technology.
technology,
Future predicted price.
and future expected price of the good.
Related goods in production.
Prices of the related goods in production. And prices of the inputs, factors of production. Any of those factors, if they change, supply curve would shift to the right or to the left. We discussed all those things in the previous class. Okay? We'll be using those today, later on, when we do comparative static analysis. We'll talk about that later. But first, let's try to understand how prices are determined in the market. That's our primary objective right now. So as I said, equilibrium in the market is given by the equality between demand and supply. Okay. So as you can see in this diagram, there is only one quantity, or one price at which the demand equals to supply. And you can see that where they intersect each other. So let me point it out here. As you can see, at point E, this is your point E, denoting equilibrium, where the demand curve intersects the supply curve. And that gives you a unique price, P star, some price, some dollar figure, right? That's unique in the sense that only at this price, demand equals to supply, right? There's no other price over here where the demand equals to supply. So this is unique in that sense. And at that price, what happens? According to the demand curve, just focus on the demand curve, the black line here. When price is P star, quantity demanded is QD star, some number, QD star, okay, from the demand curve. And now you focus on the blue line, that's your supply curve. When price is P star, what is supply equal to? QS star, which is the same thing as Q star. So one quantity. Can you see that? Quantity demanded is same as quantity supplied at the price P star. So it's unique in that sense too, right? Both price and quantity are unique in equilibrium. Is that fine with everybody? So when price is P star, quantity demanded, QD star, is same as the quantity supplied, Q star. You can call it Q star, some number. Okay? And it's unique. So that's your equilibrium, given by the intersection between the demand and supply curves. So the question I'm going to address next is, why is this equilibrium and why not some other price? So P star, I'm saying, is equilibrium price, and Q star is the equilibrium quantity that is bought and sold. The buyer's plan is matching with the seller's plan, right? Buyers want to buy QD star unit of the good, and sellers want to sell Q star of the good when the price is P star. So buyer's plan matches with the seller's plan at this price, right? And we are calling it equilibrium. But why is P star equilibrium and not something else, some other price? So let's look at it. Equilibrium, as I said, is a state of balance. You disturb it, it will come back to it, okay, on its own. So let's check another price. Let's pick, which color is good color?
Green.
Which one?
Green.
Green. This one?
Yeah.
This one? This? All right, let's pick green. So let's pick a price P1, okay, which is higher than your equilibrium price, P star. So let's suppose currently price of this good in the market is P1, okay, a higher price. So what will happen at that price? Let's look at it. So when price is P1, according to the demand curve, which is your willingness and ability to pay curve, right? How much you are willing to pay for this product. The consumers would demand only Q1 units of this good when the price is P1. Because price is now higher, consumer would demand less units of this product. But what happens to the supply here? At the same price P1, and you can see the supply is going to be higher, Q2. Can you see that? The divergence between the seller's plan and the buyer's plan. The quantities are not matching anymore, right? Price is higher, P1. Buyers want to buy only Q1 units of the good at this price. It's a high price for them. Sellers like this price. It's a higher price. They want to receive higher price for the product. Therefore, they are willing to supply more, Q2 units of the good. So now, buyer's plan don't match with the seller's plan. Can you see that? So what would you call this divergence that we see here, over here, this gap at price P1? What would you call this divergence? So supply is more than the demand, right? At price P1. What would you call it? Surplus or excess supply, isn't it? There is an excess supply of this good or a surplus of this good when the price is P1. So we have a surplus of this good. Surplus, or you can always call it excess supply. Right? So what happens when you have a surplus of a product in the market? What happens to the price of that product? It should fall, isn't it? We know that from our observation. When there is a glut or surplus of a product, price of that product would drop because sellers want to get rid of that surplus, right? By offering you discounts, lower prices so that you buy it, isn't it? They want to clear the surplus. So there will be a downward pressure on this price of this product, and price would fall in this direction. And eventually, the surplus would be cleared when price falls all the way to P star. Can you see that? When price falls all the way from P1 to P star, from here to here, now you don't have a surplus because demand is exactly the same as the supply, right? So it happens automatically. Nobody is doing anything. Government is not trying to change the price. It's the market forces of supply and demand, right? Price is behaving like a regulator. It adjusts when there's a surplus. Price comes down, right? So as you can see, when P1 cannot be equilibrium because it's not stable, price comes down to P star. Let's check another price which is below the equilibrium price. Now let's check this color. I don't think that would go well. So let's choose purple. Elmira college color. Okay, let's take a price which is P2. So now I picked a price that's below the equilibrium price, right? And let's see why that is not an equilibrium. So what happens now? Price is P2. It's a low enough price. And at this price, sellers don't have enough incentive to sell as many units of the good, right? They like to receive higher price. This price is low for them. So they would supply less. How much are they going to supply at this price, according to supply curve? Look at price P2, look at the supply curve. How much would the sellers supply at P2? Less, how much? What is the quantity? Q1. Can you see that? When price is P2, according to supply curve, quantity supplied would be Q1. Now this price is low, therefore buyers are going to like this price, isn't it? According to demand curve, buyers would demand more. They like to pay lower prices, right? So how much more? They are going to demand Q2 units of the good. Right? So what do you have now? Again, we have a divergence between the buyer's plan and the seller's plan. They don't match. So what do you call this scenario now? Over here. Shortage of the good or excess demand. That's correct. So now you have a shortage of the product at this price, P2. What happens when you have a shortage in the market? What happens to the price of that good? It will go up, right? Buyers compete now with each other to buy that product because it's in short supply, right? There's a shortage of the product. So buyers would bid up the price. There will be an upward pressure on the price and price would eventually rise all the way to P star in this direction, right? And shortage would be cleared once again. The moment price reaches P star, buyer's plan match with the seller's plan, isn't it? So what you just saw is that P star is stable. If you disturb it, you choose any other price, P1, P2, right? The price would adjust, right? Either it will fall if there is surplus, or rise if there is a shortage, and eventually come back to P star. That's your equilibrium price in the market, state of balance. Is that fine with everybody so far? How the market, determines the price of a good, and then quantities bought and sold in equilibrium. Okay. All right. So that's your how the equilibrium price and quantity are determined in the market, in a competitive market. Next, we are going to look at what will happen to this price that is determined in the market when there is a shock to the market. By shock, I mean a change in one of those factors, right, that affects either demand or supply. You remember 6 factors affecting demand, 6 factors affecting supply, right? So a change in those I'm referring to as a shock, okay? A shock to the demand curve or shock to the supply. You can also call it supply shock, demand shock, okay? Depending on which factor you're looking at. And then we want to predict what will happen to the price in the market and quantities bought and sold. So you can make those predictions here by analyzing the market, okay? So this exercise is called comparative static. Involves a lot of calculus at a higher level when you take economics. Don't worry about it. We'll just use simple graphs to understand how it's done. But if you take economics, you major in economics, and go to graduate school, you'll be doing a lot of calculus. Okay. So we are going to do comparative static. So I'm going to start with a very simple example. We'll consider a market. Let's say we are looking at, a market for red wine, my favorite product. Okay. I don't know whether you can drink, but I can drink. So that's my favorite product for the time being. So we got a market for red wine. So you're looking at quantity of, let's think of a generic version, just to keep things simple. There's no brand differentiation, it's not, you're not looking at a Merlot, Pinot Noir, things like that. You just, red wine. Just think of simple example. A bottle of red wine, right? That's your quantity. And let's say you got price of red wine over here. Okay? We're not differentiating between the French red wine, California, Napa Valley, or, coming from Argentina, whatever it is. It's a generic version, a bottle of red wine, okay, and price of red wine, just to keep things simple. And let's say you got demand for red wine, which is downward sloping, follows the law of demand. And then you have supply of red wine, which will also follow the law of supply, upward sloping. Okay, conventional demand and supply. And that we know will determine the price of red wine in the market. So let's say the equilibrium price of red wine in the market currently is, let's say, $12 a bottle. And at that, let's say, 1 million bottles are bought and sold in equilibrium. So that's your equilibrium quantity, right? Let's say you're looking at United States in a year, 1 million bottles of red wine, red wine is sold here. Okay, simple example, simple numbers. Now, next we want to predict what will happen to the price of red wine when there is a demand shock or supply shock. Okay, what will happen to the quantities bought and sold? That's our objective next. So let me give you 2 pieces of information, okay, which you can call shocks, basically, to to the demand and supply curves. So the first piece of information that I'm going to give you is that, let's say, researchers found that if you drink red wine in moderate amounts every day, preferably with your dinner, you are going to live longer. Okay? Suppose that's what we found, the researchers found, which is actually true. I mean, that's what researchers have found. If you drink red wine in moderation, and if you're a male, you should drink 2 glasses a day with your dinner. If you are a woman, drink 1 glass. You're not allowed to drink more than that. So that's called moderation. And if you drink regularly, you tend to live longer than those who don't. That's what the researchers have found. Okay. So suppose that's what that's the piece of information you get. Actually, red wine has a substance called resveratrol, and that has been found to be associated with longevity. That's why they say red wine is good for you in moderation. But that's not a reason why you should start picking up red wine if you don't drink altogether. And so if you don't drink at all. If you are already drinking, drink in moderate amount. That's the recommendation. All right, so suppose that's the piece of information you have. So the question I have for you, what will happen to the demand for red wine? It will increase because
more people are going to want it.
What is it?
More people will want it.
More people would like to drink. They will change their preference, right? Taste and preferences, remember that? Six factors, one of the 6 factors. This piece of information, the new research, is basically going to change people's taste and preferences, right? If you're drinking beer, maybe you will switch to red wine. If you're drinking whiskey, you might give it up and start drinking red wine. Those who were not drinking, they might pick up drinking red wine, something like that, right? So it will alter your preferences in favor of red wine. People want to live longer, and that's what might happen. So at $12 earlier, before we got this new research, 1 million bottles were sold, right? Now you would expect more bottles to be sold at the same price, right? So we know that demand curve will shift to the right. So let me shift your demand curve to the right. So let's say demand shifts by this much. That's your new demand for red wine. Is that fine with everybody so far? So let's suppose for the time being, nothing happens to the supply of red wine. There is no shock to the supply. None of the factors, 6 factors, that we kept constant when we drew supply for red wine are changing. Okay? So if nothing happens to supply, you would expect price to, what happens to the price? Price will rise to maybe $15, some higher number, some hypothetical. So you're moving along the supply curve, as you can see, to this point. That's your new equilibrium in the market. And maybe 1.5 million bottles would be sold in equilibrium. Can you see that? So this is called a demand shock, right? Something happened, outside of this market, but has a bearing on the market. It's going to influence the market, right? Researchers were doing research for their own purpose. They want to get publication, they want to get raise for themselves, right? And things like that. But it affects the market for red wine. And something like this happened a few years ago. I remember there was a movie called Sideways. Have you seen a movie called Sideways? It was nominated for Oscars, maybe won some Oscars, some category. I think we were looking at year 2005 or something like that. Around that time, 4, 5, 6. I don't exactly remember. But there was a movie Sideways, and in this movie, they showed, the main actor, he was heavily into Pinot Noir, a type of red wine, and he hated Merlot, another type of red wine. Before that, in America, people would like Merlot. A lot of people were buying Merlot, right? But because of this movie, nobody was buying Merlot. People were just buying, Pinot Noir. It just changed the preferences of people altogether. And Pinot Noir went up in price because of that movie. right after that movie, I couldn't find Pinot Noir on the shelves. So it just changed the preference of the people. Anyway, so that's one thing. Now let me give you another piece of information next. Let's say south of France experienced unusually warm weather. So summer were like very, very hot. Okay. What will happen in this market as a result, and why?
Supply will decrease.
Supply will decrease because
They don't.
what will happen because of warm weather, unusually hot conditions in south of France.
They don't have all the grapes that they need.
South of France is known for grape, right? And hot weather is not conducive to grape cultivation, right? So it might affect grape production and might affect supply of wine in general and red wine in particular, right? So you would expect supply curve to shift to the left. Okay. So supply of red wine would shift to the left, like this. That's the supply curve, it shifts, decreases actually, because of this piece of information. So basically, one of the factors that affect supply curve had changed, right? A natural disaster or weather conditions, things like that, right? That's what you're looking at here. That changed, and supply is going to shift to the left. So now, what happens? You are moving along the new demand curve over here, and that's your equilibrium. So what happens to the price?
Increases.
Price increases further because of this condition. Maybe it will sell for $17 a bottle. Quantity, in this diagram, it looks like quantity goes back to the original amount, right? But we cannot predict about quantity. What will happen to the quantity? We don't know unless we have more information. Unless we know by how much the demand curve is shifting to the right and how much supply curve is shifting to the right. Unless we know the magnitude of the shift, we can't predict what will happen to the quantity. So the way I have drawn in this diagram looks like quantity bought and sold in equilibrium goes back to the original quantity, 1 million, right? But it can be less than 1 million, it can be more than 1 million, depending on what is the magnitude of the shift, right? The only thing we can predict here with certainty, because of these two events taking place, that the price of red wine will go up. That we can say with certainty, isn't it? Is that fine with everybody? What is happening? So that's an example of what we call is comparative static. So what you're doing is you are giving the market some kind of shock, external shock, right? It's happening outside of the market, but has bearings for the market. Okay, something happened, and it's going to come to affect the market, right? Weather conditions were not good, conducive in south of France for grape cultivation. That affects the market for red wine here in America. Researchers found something. Beneficial effect of red wine on your health. It has bearing for the price of wine and so on. Okay.
Can you explain why the supply curve moves to the left?
Why? Okay. So let's say price was $12 and supply was 1 million at that point initially. That's your starting point. Now what happens is we know weather conditions are not favorable in south of France. Therefore, grape production would decrease. Can you see that? And if you have less grapes, you'll have less grape juice to make wine, right? So we know at the same price, $12, now there will be less supply of wine. So maybe instead of 1 million, you will have only half a million. Can you see that? So basically that falls on a new supply curve. So supply curve decreases, shifts to the left. Okay. All right, good. Fine so far? Everything clear? If not, let me know. Okay, good. Let's do one more thing and then we'll stop. That will cover your chapter 3, I think, right? Yeah, we're in chapter 3. Let's look at how we can find equilibrium, price and quantity using simple math. Okay? And that we can do next. So first you need to know what is demand function, what is supply function. Okay. So I'll give you the demand first. So demand is given by, let's start with a generic, equation, and then we'll use specific numbers. You can calculate numbers. So let's start with the generic one. So demand is, let's say, given by price equals to A minus B times QD, where QD represents quantity demanded. Okay? And P is the price of the good. So this is your price of the good, and QD is quantity demanded of the good. So you are looking at relationship between price of the good and quantity demanded of that good. A is your y-intercept. And B is your slope of the demand curve. So those are the interpretations of the symbols we have here, the letters we are using. Now let me draw a diagram to capture demand curve. So over here, we got quantity here and price. So look at this equation. Tell me, what is the price at which quantity demanded equals to 0? Nobody buys. Price is too high. Nobody buys anything. What is that price equal to? A, that's correct. You just substitute QD equals to 0 over here. And you are left with price equals to A. So let's say price is here, A. So when price is A, quantity demanded is 0. Okay? Is that fine with everybody? So that's your y-intercept. And after that, as you can see, it has a slope of negative b, right? Slope is negative b here. So if you draw it, it will, or you can, what you do is you need another point to draw. At what, let's suppose price is 0. What is the quantity demanded equal to at that price? Hypothetical price. Let's say price is 0. You give the product for free. How much would be demanded? Can you tell me? Price is 0, so it's free. Okay, how much would be demanded of this product? You have to give me a specific expression for it. Substitute P equals to 0, solve for QD. What do you get? Question is, what is the quantity demanded equal to when price is 0? So plug in P equals to 0, solve for QD. What do you get? A over B, that's correct. So let's say A over B is here. Some expression. If you know A and B values, you will know that. And you connect them, that gives you straight line demand. That's your demand. It has a slope of negative B. We already know that from that expression. But you can also calculate slope by looking at rise over run. Isn't it? You got the points, 2 coordinates, A and 0, and A over B and 0, right? You can use that to calculate slope, rise over run, and it will give you negative B. So that's an exercise for you, okay? You can calculate slope here, but we already know slope is negative B just by looking at the equation. Is that fine with everybody so far? So that's your demand curve. Next, let's talk about supply curve. So let's go to the new slide. I'll do a numerical exercise as well. So supply is the relationship between price and quantity supplied. Again, price equals to C plus D times QS, where P is the price of the good, QS is the quantity supplied, D is the slope of supply curve, positive as you can see, and C is your intercept. y-intercept. Similar to demand curve. The only thing is that the slope is positive here. Okay. So next let's plot supply curve. You got quantity over here and price. So at what price supply is 0? The firm does not supply any unit of the good. What is the price at which firm would not supply anything? C, that's correct. Just plug in QS equals to 0, you'll get C. So this price is low enough, The firm does not think it's worth supplying the product because it's not able to recover its marginal cost of production. This price is very low. And after that, we know it's a straight line equation. And it has a positive slope of t, right? Whatever that number is will tell you what is the supply curve. So it goes like this. That's the supply curve. Slope will determine whether it's going to be flatter, steeper, and so on. So it's straightforward. Just draw a positive line. Depending on the slope, you can draw a flatter or a steeper line. So that gives you supply curve. Next, we want to find out equilibrium price and equilibrium quantity using this information. Isn't it? And so let's move on to that one.
It's gross.
So let me draw the diagram first. So that's your demand curve, A over D, and this is your A, and that's your supply curve. So we are interested in finding this, P star and Q star. So our objective next is to find P star and Q star, equilibrium price and equilibrium quantity, given the information we have. So we know equilibrium is defined by demand equals to supply, right? When demand is equal to supply, we'll give you equilibrium price and quantity. So to find equilibrium, the only thing you have to do is set supply curve, set a supply function equal to the demand function.